Hello, math friends. Welcome back. Today, we are stepping into a delicious part of mathematics, Chapter 4, Ratios, Rates, and Proportions. Think about your favorite cookie recipe. To make the dough just right, you need a specific balance of flour to sugar. If you add too much flour, it's dry. Too much sugar, and it's a sticky mess. That balance, that is exactly what a ratio is. In this chapter, we're going to learn how to compare quantities, how to find the best deal at the grocery store using unit rates, and how to translate between the three languages of money: fractions, decimals, and percents. Grab your notebook and a snack, and let's get started. First up, let's talk about ratios. Simply put, a ratio is a comparison of two quantities using division. It tells us how much of one thing there is compared to another. Imagine we have a fruit basket. Inside, we have 3 red apples and 2 yellow bananas. We can write this comparison in 3 different ways, but they all mean the exact same thing. First, we can use the word to, like this, 3 to 2. Second, we can use a colon, those 2 little stacked dots, 3 to 2. And third, which is very common in algebra, we can write it as a fraction, 3 over 2. Let's try a different example to see the difference between part to part and part to whole. Suppose a classroom has 12 boys and 18 girls. If I ask for the ratio of boys to girls, part to part, we write 12 to 18. But just like fractions, we love to simplify. Both numbers are divisible by 6, so the simplified ratio is 2 to 3. For every 2 boys, there are 3 girls. Now, what if I asked for the ratio of girls to the total students, part to whole? First, we find the total. 12 plus 18 equals 30 students, so the ratio is 18 to 30. If we divide both by 6 again, we get 3 to 5. That means 3 out of every 5 students are girls. See? It's all about what you are comparing. Next, let's level up to unit rates. A rate is a ratio that compares two quantities with different units, like miles and hours or dollars and pounds. A unit rate is special because it tells us the rate for exactly one unit. Think of the word per, like miles per hour, or price per item. Per basically means for one. Let's look at 2 scenarios where this is super useful. Scenario A, the grocery store. You see a bag of 5 avocados selling for $10. You want to know, how much does just one avocado cost? To find the unit price, we divide the money, $10, by the quantity, which is 5. So the unit rate is $2 each. Easy peasy. Scenario B, speed. Imagine you are on a road trip and you drive 150 miles in 3 hours. How fast are you going? We need the miles for 1 single hour. We set it up as a fraction with hours on the bottom because we want that to become 1. We divide 150 by 3, which gives us 50 miles per hour. This tells us that for every single hour that passes, the car travels a distance of 50 miles. That is your unit rate. Whenever you need to compare prices or speeds, always divide to find out what 1 unit is worth. Now that we know ratios, let's talk about proportions. A proportion is just a fancy way of saying 2 ratios are equal. It's like an equation, but for fractions. Sometimes one piece of the puzzle is missing, and we have to find it. We have 2 main ways to solve these. Method 1, the multiplier, scaling up or down. Look at this proportion. 3/5 equals x over 20. Ask yourself, how do I get from 5 to 20? We multiply by 4. Since we treated the bottom with a 4, we must treat the top with a 4 to keep it fair. 3 times 4 equals 12, so x equals 12. Method 2. Cross products, the butterfly method. Sometimes the numbers aren't as friendly. Let's look at 4/9 equals x over 6. You can't easily multiply 9 to get 6, so we use the butterfly method. We multiply the numbers diagonally across from each other. 9 times x equals 4 times 6. This gives us 9x equals 24. Now we solve for x by dividing both sides by 9. X equals 24 over 9. We can simplify that fraction by dividing by 3. So x equals 8/3, or roughly 2.67. Both methods work, so use the one that looks easiest for the numbers you have. Have you ever looked at a map on your phone? You can see whole cities on a tiny screen. That is a scale drawing. It represents real objects, but at a size we can manage. The scale tells us the ratio of the drawing size to the real-life size. Let's try a classic map problem. Suppose a map has a scale of 1 inch equals 50 miles. You measure the distance between two cities on the paper, and it is 4.5 inches. How far apart are they in real life? We know the scale is 1 inch to 50 miles, and we measured 4.5 inches. We want to find the real miles, which we will call x. So we set up a proportion. Think of a proportion like a mirror. The left side reflects the right side. On the left side, we put our key or legend, the rule the map gave us, 1 inch over 50 miles. On the right side, we put our measurement, what we actually found with our ruler. Since we put inches on the top left, we must put inches on the top right. We measured 4.5 inches, so that goes on top. We don't know the real miles yet, so we put an X on the bottom. Now let's use the butterfly method to solve this. It works every time. We are going to multiply the numbers diagonally across from each other. First wing, we multiply 1 inch times x. So on the left side, we have 1 inch times x. Second wing, we multiply 50 miles by 4.5 inches. So our equation looks like this. Now we want to get x all by itself. Since x is being multiplied by 1 inch, we need to do the opposite. Divide both sides by 1 inch. Here's where the math magic happens. Watch the units. On the right side, we have inches on the top and inch on the bottom. They cancel each other out. Poof, they're gone. The only unit left standing is miles, which is perfect because we're looking for a distance. Now we just do the arithmetic with the numbers. 50 times 4.5 equals 225. So x equals 225 miles. Point A and point B are 225 miles apart in real life. Now let's try the reverse. Imagine you're designing a toy action figure based on a giant movie robot. The packaging says the scale is 1 to 24. This 1 to 24 ratio acts like a shrink ray. It tells us that the real robot is 24 times bigger than the toy. Here's the data. The real-life giant robot stands 144 inches tall. We need to figure out how tall the action figure will be. Since we're going from the big object, the giant robot, down to the small object, the toy, we need to make the number smaller. In math, when we scale down, we divide. We take the real height and divide it by that scale number, 24. If you calculate 144 divided by 24, you get exactly 6. So, your robot action figure will be 6 inches tall. We are about to meet the 3 best friends of the number world. We have fractions, decimals, and percents. Think of these as the same person wearing 3 different outfits. Whether you are wearing a swimsuit, a tuxedo, or pajamas, you are still you. In the same way, 1/2, 0.5, and 50% are all the exact same value. They are just dressed differently for different occasions. The word percent literally means per 100. Think of a century, which is 100 years. Here is the secret code. Look at the number 100. It has exactly 2 zeros. Those 2 zeros tell you exactly what to do. You always move the decimal point 2 spots. 2 zeros, 2 jumps. It is that simple. Let's learn the moves. First, percent to decimal. To remove the percent symbol, we move the decimal 2 spots to the left. A fun way to remember this is alphabetical order. To go from percent to decimal, you go backward in the alphabet, so you move the dot backward, left. Example A. Take 75%. The decimal is hiding at the end. Move it left twice. Jump, jump. It becomes 0.75. Example B. What about a tiny percent, like 5%? Move the decimal left twice. The first jump gets you to 0.5, but for the second jump, there's no number there. We have to plant a placeholder 0, so it becomes 0.05. Now, decimal to percent. We do the exact opposite. To add a percent sign, we move the decimal 2 spots to the right. Alphabetical tip. D comes before P, so we move forward to the right. Example, take 1.25. This is greater than 1, so we expect a big percent. Move the dot right twice. Jump, jump, it becomes 125%. Fraction to percent. This is a 2-step dance. We can't go straight from a fraction to a percent. We have to stop at decimal station first. Step 1, the division. First, we turn the fraction into a decimal. We actually covered the nitty-gritty of this back in Chapter 2, so if you need a full refresher on converting fractions to decimals, pause here and go check out that video. Let's take 3/8. We divide the top number, 3, by the bottom number, 8. When we do the division, we get 0.375. Step 2, the move. Now that we have a decimal, we convert it to a percent. Remember our rule. To go from decimal to percent, we move the point 2 spots to the right. Look at 0.375. Find the dot. Jump 1, it hops over the 3. Now it looks like 3.75. Jump 2, it hops over the 7. Stop. Plant the decimal right there between the 7 and the 5. Add the percent sign at the end. So our final answer is 37.5%. Last but not least, let's go from percent to fraction. This one is actually the most literal translation. Remember, percent means per 100. So to turn a percent into a fraction, you just put the number over 100. Step 1. Drop the percent sign and write the number as the numerator, the top, and 100 as the denominator, the bottom. Let's try 60%. First, we write it as a fraction, 60 over 100. Step 2. Simplify the fraction if you can. Technically, this is correct, but in math, we always want to look our best, so we simplify. Both numbers end in 0, so we can divide both of them by 10 to get 6/10. They are both still even numbers, so we can divide them by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5. So 60% is equal to 3/5. Remember, fractions, decimals, and percents are just different outfits for the same value. Keep that 2 zeros, 2 jumps rule handy, and you'll be translating between them like a pro. Finally, let's put those percents to work. We often face word problems like, what is 20% of 50? Or 30 is 50% of what? Or 10 is what percent of 100? To solve these, you don't need to guess, you just need to be a translator. We're going to translate English sentences into math equations using this simple translation checklist. Step 1. Spot the is. Change it to an equal sign. Step 2. Spot the of. Change it to a multiplication sign. Step 3. Spot the what. Change it to an x. Step 4. Spot the percent. Turn it into a decimal immediately. Let's test our checklist on 3 different examples. Example 1. Finding the part. The question is, what is 15% of 40? Let's run the checklist from left to right. What becomes x? Is becomes equals, 15% becomes 0.15, of becomes multiply, and 40 stays 40. Now we have a clean equation. X equals 0.15 times 40. To solve it, we just multiply. 0.15 times 40 equals 6. So 6 is 15% of 40. Example 2. Finding the whole. The question is, 12 is 30% of what number? Let's run the checklist again. 12 stays 12. Is becomes equals, 30% becomes 0.30, of becomes multiply, and what number becomes x? Our equation is 12 equals 0.30 times x. To get x by itself, we need to undo the multiplication. So we divide both sides by 0.30. X equals 12 divided by 0.30. Here is a cool trick for dividing by decimals. We don't like decimals in the bottom, so move the decimal 1 spot to the right to make it a 3. But to be fair, you must move the invisible decimal in 12 1 spot right to make it 120. Now it's just 120 divided by 3, and 120 divided by 3 is 40. So 12 is 30% of 40. Example 3. There's one last flavor of problem, when they give you the numbers but hide the percent. Let's try this one. 20 is what percent of 80? Don't panic, just trust the checklist. 20 stays 20. Is becomes equals, what percent becomes our unknown x, of becomes multiply, and 80 stays 80. So our equation is 20 equals x times 80. We want x alone, so we need to get rid of the times 80. The opposite is dividing by 80. X equals 20 divided by 80. Now we simplify that fraction. Both end in 0, so we can chop those off to 8ths. That simplifies to 1/4. And from our decimals chapter, we know that 1 divided by 4 is 0.25. Wait, we aren't done. The question asked for a percent, but we have a decimal. Apply the 2 zeros, 2 jumps rule. Move the decimal 2 spots to the right. 0.25 becomes 25%. So 20 is 25% of 80. You made it! We've covered a lot of ground today. We started by balancing fruit baskets with ratios, shopped for the best deals using unit rates, and used proportions to scale maps and solve puzzles. Finally, we mastered the language of percents and learned how to translate word problems into math equations. Remember, ratios and proportions are everywhere, from the screen you're watching this on to the money in your pocket. Thanks for learning with me today, and I'll see you in the next chapter.